If you look at a map of the ancient world, four major civilizations stand out. Alongside Egypt, Mesopotamia, and China, the Indus Valley Civilization controlled a massive stretch of territory along the Indus and Sarasvati rivers in what is now Pakistan and northwest India. This society took root around 3300 BCE and reached its peak of influence roughly between 2500 and 1900 BCE. But if you look at their architectural footprint, something is missing. Archaeologists have never found massive religious temples, giant royal palaces, or any clear documentation of an organized army. Instead, they built grid-patterned streets with remarkable engineering precision. Excavated sites reveal indoor sewage systems in nearly every home, standardized granaries, and uniform weights and measures for widespread trade. The evidence points to a massive population organized entirely around civic administration and commerce, rather than centralized royal or military authority. Around 1900 BCE, this stability began to fracture. Over several centuries, these meticulously engineered cities were gradually abandoned. The ruins resemble an empty crime scene. There are no signs of struggle, no scattered weapons, and no layers of ash suggesting a foreign invasion. For decades, historians assumed a military conquest must have caused their downfall, but the physical excavations repeatedly failed to support that theory. If it wasn't a sudden war or a massive catastrophe, something more subtle had to be responsible for the vacancy of these cities. In late 2025, a study published in Communications, Earth and Environment offered a look into the region's ancient environmental shifts. Scientists bypassed the human ruins entirely and looked at geology. By combining water level records from 5 local lakes with mineral data found inside stalactites and stalagmites in Indian caves, they found a record of ancient rainfall locked in the rock. This graph charts that geological data, giving us a reconstruction of the region's climate history stretching back thousands of years. Where human artifacts fell silent, the Earth itself had preserved the critical records of the civilization's final centuries. The researchers identified a clear pattern. Between 4,450 and 3,400 years ago, the region was hit by 4 distinct long-term droughts. Looking at this timeline, you can see the severity of the drop. Each of these 4 troughs represents a drought lasting more than 85 years. During these periods, annual rainfall dropped by 10 to 20%, while average temperatures rose by half a degree Celsius. As the data maps onto the region, it shows that these droughts affected between 65 and 91% of the total territory occupied by the Indus Valley Civilization. The researchers emphasized that this was a gradual decline. Repeated centuries-long droughts put a severe and unyielding strain on the river systems they depended on for drinking water and farming. Standardized weights and indoor plumbing offered no defense against a systemic, irreversible failure of their local ecology. The climate data matches the archaeological movement of the people. Around 4,500 years ago, populations began abandoning areas dependent on rainfall, clustering closer and closer to the main Indus River. An earlier study from the Woods Hole Oceanographic Institution helps explain why. They had to flee from another primary water source, the sacred Sarasvati River. This split-screen comparison shows the geographic vulnerability. While the Indus River was reliably fed by melting glaciers in the Himalayas, the Sarasvati depended heavily on seasonal monsoon rains, leaving it susceptible to prolonged drought. As the rivers dried up, the societal structure unraveled. Trade networks slowly fractured, agriculture retreated, and major urban centers fragmented into smaller, scattered settlements. The specific geography and climate that allowed the Indus Valley to flourish were the exact same forces that slowly starved it of water. Though the climate data gives us the mechanics of their fall, we still cannot read their records. To this day, the Indus script carved into these stone seals has never been deciphered. Even with their written language lost, the physical sites of Mohenjo-Daro and Harappa still stand today as UNESCO World Heritage Sites. These empty brick grids serve as a reminder of an advanced, peaceful society that wasn't defeated by human armies, but outlasted by a changing planet. Thousands of years ago, a civilization emerged that would shape the ancient world, but like every empire, it eventually met its end. In what is now modern-day Turkey, the Hittites built one of the most powerful empires of the ancient Near East, beginning around 1600 BCE. While competing armies were still relying on bronze, the Hittites gained a massive military edge by mastering advanced ironworking. Their power grew so immense that they faced the Egyptian Empire head-on at the Battle of Kadesh. To understand the scale of this conflict, we can look at the physical evidence left behind. This was one of the largest chariot battles in ancient history, involving thousands of combatants. Despite the massive armies, the battle ended in a stalemate. The result was the first documented written peace treaty in history between two opposing sides, recorded directly onto clay tablets. By the 13th century BCE, the Hittites were a deeply entrenched, technologically advanced superpower. To outside observers, they likely seemed invincible, but within a remarkably short span, between 1200 and 1150 BCE, that entire empire completely unraveled. The timeline of their final days is a historical blind spot. The last documented king, Suppiluliuma II, took the throne around 1207 BCE. Within just a few years, all mention of him vanishes from the historical record. We know how it ended for their capital city, Hattusa. The sprawling stone settlement was burned to the ground and completely abandoned. This map shows the regional scope of the disaster. Far beyond the borders of Anatolia, every major power, from Egypt and Mesopotamia to the Mycenaean Greeks, plunged into a simultaneous crisis. How does a deeply interconnected web of advanced civilizations vanish almost overnight? For decades, historians pointed to a primary suspect, the Sea Peoples. These were a coalition of sea-born raiders repeatedly mentioned in Egyptian texts from the era. Today, the historical consensus has shifted. Researchers now understand that the Sea Peoples were likely refugees fleeing their own collapsing homelands. They were a symptom of the crisis, not the root cause. To find out what actually happened, we have to look at the physical environment. In 2023, a study from Cornell University analyzed ancient tree rings from Anatolia. This diagram of a tree trunk cross-section shows the evidence they found. By looking at these extremely narrow, tightly packed rings, researchers pinpointed a severe megadrought that choked the region for 3 solid years, from 1198 to 1196 BCE. The drought did more than just kill crops, it paralyzed the state. Without a harvest, the Hittite tax base evaporated, leading to mass desertions from a military that could no longer be paid or fed. This map illustrates the supply chain vulnerability that doomed them. Unlike Egypt, which could use its river-fed ports to import grain during emergencies, the landlocked, mountainous Hittite core had no way to replace its food supply. With the military in retreat and the treasury empty, the very foundation of the empire disintegrated from the inside out. But a 3-year drought doesn't explain a regional collapse on its own. A 2026 study from Stockholm University provides the broader context by reconstructing 8,000 years of Mediterranean climate history. This chart illustrates an 8,000-year gradual downward slope, showing the region drying out due to shifts in Earth's orbit. The most extreme droughts hit when multiple Atlantic climate cycles aligned. The drought that broke the Hittites occurred when all distinct factors bottomed out simultaneously. The environmental disaster quickly triggered an economic one. The international tin trade network collapsed, immediately crippling the production of bronze across the entire region. On top of famine and economic ruin, geologists point to an earthquake storm. This was a series of intense seismic events that struck major urban centers across the region, physically leveling the administrative hubs of the state. When you combine sustained climate aridity, a broken trade network, and a series of devastating earthquakes, the mathematical chance of any empire surviving drops to near zero. In the aftermath, the Hittite Empire fragmented entirely, shattering into small, isolated city-states. The Eastern Mediterranean fell into a dark age. It would take centuries of recovery before new societies, like classical Greece, eventually emerged from the region. Yet something crucial survived the fires of the capital. When Hattusa burned, the intense heat actually baked their massive archive of clay cuneiform tablets, preserving them in the ashes. Today, these recovered texts give historians an incredibly rare window into the law, politics, and religion of a people who seemingly vanished overnight. Climate shifts and systemic fragility can erase a powerful empire in a matter of decades, but the records they leave behind can endure for millennia. Every great empire eventually meets its end. No matter how advanced the engineering or how complex the society, the monuments of the past inevitably disappear under the weight of time. Deep in the jungles of Central America, stretching across modern-day Mexico, Guatemala, and Belize, the Maya constructed one of the most scientifically literate societies of the ancient world. They tracked the movements of the stars to build an incredibly precise astronomical calendar, and they recorded their history using a dense, highly sophisticated written language of hieroglyphs. Their mathematicians were also working at an elite level, independently inventing and applying the concept of zero long before the idea ever reached Europe. By the height of their classic period, between the 3rd and 9th centuries CE, the sheer scale of their engineering and agriculture meant these Maya cities were operating as some of the largest, most densely populated urban centers on the planet. Then, roughly between 750 and 900 CE, during a period known as the Late Classic, a severe and sudden disruption tore through the region. Across the southern lowlands, major cities were systematically abandoned. The carving of royal inscriptions stopped, and the construction of massive stone monuments halted entirely. A persistent myth is that the Maya people vanished into thin air. They didn't. Their culture endured, and millions of their descendants still live in the exact same region today. What actually collapsed was the centralized political apparatus, the sprawling, highly organized system that governed those major city-states in the south. The enduring historical mystery is not where the population went, but what specific force possessed enough destructive power to completely shatter such a massive political machine. For decades, the leading hypothesis among archaeologists and historians has been severe drought. In August 2025, a team of researchers from the University of Cambridge published what appeared to be the most precise evidence ever gathered to support that theory. By analyzing chemical signatures inside a stalagmite from the Grutas Sabno cave in Mexico, the team was able to measure ancient rainfall levels season by season between the years 871 and 1021 CE. This chart reveals their discovery, a catastrophic 13-year consecutive drought, plus 7 other multi-year dry periods. When we overlay the archaeological record, the timeline of halted monument construction lines up perfectly with the deepest troughs. For a brief moment, this paper stood as the strongest direct link ever found between an acute climate disaster and the political collapse of the Maya. But just a few months later, in November 2025, researchers from the University of Montreal published a study taking the exact opposite angle. They examined 3,300-year-old sediments from Laguna Itzan in Guatemala. The data showed that this specific area maintained a relatively stable, healthy climate during the Late Classic, yet its population still mysteriously vanished. This led the Montreal team to a very different thesis. The collapse was not a single, uniform weather event that struck the entire civilization evenly. Instead, they proposed a wave theory. The city-states were a highly connected network. If drought hit a neighbor, it triggered human migration. That shock rippled outward along trade routes, causing a cascading failure that dragged down climatically stable communities. Urban modeling from UC Santa Barbara suggests that the rapid growth and economics of scale that built these massive cities up in the first place became fatal vulnerabilities once environmental conditions shifted. The tight interconnectivity and heavy urbanization that made the Maya a superpower ultimately ensured that a crisis in one province would become a crisis for all of them. While these modern systemic theories explain how the collapse spread, older, traditional historical factors explain why the society was so brittle to begin with. Decades of intense deforestation and the heavy overexploitation of agricultural land had deeply weakened the soil, destroying its ability to absorb and hold water whenever droughts did occur. At the same time, fierce, recurring wars between rival city-states drained critical labor and resources precisely when the region desperately needed to cooperate. Finally, the entire Maya political hierarchy relied on the belief that the king served as a divine intermediary, uniquely capable of communicating with the gods to bring the rain. When those divine promises failed year after year, the bond between the rulers and the ruled dissolved, leaving the kings with no authority to manage the worsening crisis. there is one last piece of evidence that thoroughly complicates the idea of a single civilization-ending doomsday event. Several major cities in the northern Yucatan, such as Chichen Itza, actually continued to thrive for centuries after the southern lowlands were largely abandoned. The survival of these northern metropolises solidifies the current scientific consensus. The collapse of the Maya was driven by a complex web of highly localized, overlapping factors, not a uniform extinction event. Despite the massive influx of new geological and modeling data published in 2025, archaeologists and climatologists are still fiercely debating how to interpret the timeline. The Maya built a political and economic machine so intricately connected that well over a millennium later, modern science is still struggling to reverse engineer exactly how it broke.